That said, there is a fourth way. And this, I think, was like almost already being supported, but we had to do just like a minor tweak of FlightKit Python to get this off the ground. But this is kind of a preview, and it will require FlightKit 0.24 or greater. And basically, this is a locally built flight snacks. I'll be pushing this up later today / this week. And so really the use case for decorating tasks and workflows is I'm like quickly experimenting or prototyping, or even I just want to use decorators, like this pattern that's quite useful in Python. You're familiar with it. But I can use decorators to then modify the behavior of tasks in the same way that I would decorate any old Python function to modify its behavior. So if we just take a peek at this single decorator example, I'm defining this log.io function, which is a decorator. And I'm defining within it a wrapper function that will wrap this input function here and the log.io function here. But I'm going to modify what happens before and after calling this function. So in this case, I'm just going to log the inputs and outputs of whatever function I've passed into log.io. And then also I'm going to log the output of whatever is output by function. Great. So this is like regular Python code. This should work, in Python. But it also works in Flight now. And here the invocation of the decorators matters. So the @task decorator that we're all familiar with in FlightKit should be the outermost decorator. And here I'm just decorating T1 with log.io. And I'll show you later in a sandbox environment, this actually works. I can also stack multiple decorators. So here I'm defining a validate output decorator. Same pattern. Oh, sorry, by the way, stepping back a little bit, this @wraps functools kind of utility function makes sure that this wrapper thing that's being returned as part of the output of this decorator, this makes sure that the function signature, the doc string, and all of that stuff is bubbled up to the top level wrapper. So FlightKit can analyze this wrapper function and see, oh, okay, it's exactly the same function signature as the decorated function. Okay. So really this validate output decorator is pretty simple. It just looks at the output and checks whether it's a positive number. So if it's less than or greater than, or if it's less than or equal to 0, it's going to error out. So now that we have these two decorators, I'm going to first validate the output of T2, which is this new task I'm defining here, and then logging the inputs and outputs of it. And we can, string this together in a workflow, and I'll show you a little bit later. This should work. Actually, I'll show you now. So here's the sandbox environment. I won't execute this thing, but just to show you the logs of it. Yeah, decorating tasks. So our decorator logger actually logs the inputs and then the outputs of this thing. So this was, our decorator at work. So that's great. I guess one caveat here is that manipulating the function signature of the inner function is not fully tested. I haven't quite thought through the consequences of this, but really, yeah, any pattern that relies on this @wraps decorator pattern will work in FlightKit. Next, I'll show you decorating workflows. This requires a little bit more work But if you want to do something like establish a setup teardown pattern that relies on an external service, you can inject tasks into a workflow function body using decorators, which is pretty neat. So in this example, I'm just going to mock out an external service. So this external service has some initialize and some complete method. For people who are familiar with weights and biases or PRML or similar types of packages, you can see like weights and biases have, and both of these libraries have this kind of API where you initialize something with some ID and some other metadata, and then you can complete it, mark it as failed or complete at some point during execution. But in this case, I'm defining two tasks, setup and teardown. And this doesn't rely on any state or any inputs and outputs from my main function body, like the workflow body, which is where this works very well. And then I define a workflow decorator. And this is kind of similar to the decorator I defined for tasks. But here I'm doing a little extra work. We might refine this example to make it seem a little less like we're kind of dissecting and doing all sorts of operations inside of a workflow. But basically what's happening is I'm getting the current context of the current flight context. I'm creating a node. And this before argument is a task. This is a flight task. So I'm creating a node here to produce a before node. I'm executing the workflow function body. So this then makes the compilation state consist of the before node and then the bunch of nodes that this function produces. And then the after node, which is the same thing. And basically the compilation state of the workflow looks kind of like this, simplified version. And then this conditional just checks, whether there is a compilation state when this wrapper is being executed, and then makes sure that the before node executes before the first workflow node, and then the after node executes after the last workflow node. I'm doing a few more tricks here, like this partial thing in order to make setup and teardown a parameterizable decorator. So I'll show you what that looks like. I define two, very simple tasks just to show, to illustrate the point. And here I decorate this workflow. Again, the invocation matters. So workflow needs to be at the outermost decorator. And the setup teardown decorator takes in the setup task and the teardown task, and does some magic. So I'll show you. This is the sandbox environment. This is a succeeded thing. We can see that setup executes here, our T1 and T2 executes, and then there's the teardown. So our graph looks like this now. So this is pretty neat. I know that we have a few things like exceptions and error handling in workflows, but those things aren't, still working on those. And so this is a really neat way of at least writing the setup teardown pattern in workflows. A caveat is if any of these error out, this teardown I don't think will execute. But I guess there will be ways of doing that in the future. And that is it for the demo. Again, this will be released as part of the 0.24 release. And yeah, I'm excited to see what kinds of interesting things come out of exposing this new feature.